everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I will be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So please do subscribe to my channel. So in my last video, I was explaining the 10th chapter of 9th standard science subject that was on work and energy. So from this particular video, I will be starting the new chapter of 9th standard science subject, and this is the last chapter with respect to physics. So this is the 11th chapter of 9th standard science subject that is based on sound. So what do you mean by sound? So in our previous video, we have discussed about various forms of energy. So sound is also a form of energy. So sound is also a form of energy which is produced when there is vibration of any molecules at its mean position. So for example, if you have a particular object like this, so let me consider a tuning fork. So this you can find in the physics laboratories in your schools. So if you have a tuning fork like this, and if you hit this particular tuning fork hard onto an object, so let's say if you have a rubber pad like this, so this is tuning fork, and this tuning fork is hit against a rubber pad. So when this tuning fork is hit against a rubber pad, what you can observe is that that particular tuning fork produces sound. So for example, if you keep that particular tuning fork near your ear, so there you can clearly notice the sound which has been produced by the tuning fork. So when you carefully observe that tuning fork, you can see that tuning fork's edges will be vibrating. So for example, this edges of tuning fork will be vibrating with its mean position. To and fro motion. So from its mean position, the forward and backward motion of that particular object along with its mean position, so that creates to and fro motion, which is much more regular. We have supplied certain amount of mechanical energy onto that tuning fork. So because we have supplied mechanical energy to this tuning fork has started vibrating, and that energy which we have supplied has been converted into sound energy through vibrations of this particular tuning fork. So when a particular object or any source which creates sound, that particular time that object will be vibrating at its mean position. So that is to and fro motion will be there for that object. It creates some kind of high pressure and low pressure regions around it. So for example, when this tuning fork is hit on a rubber pad, so the air molecules which are there around this tuning fork, so that air molecules which are there around this tuning fork, so there will be high pressure region and low pressure region created by this vibrations. So because this particular tuning fork will be vibrating, so at that time the air molecules which are there near this tuning fork will be having certain high pressure. So that means these air molecules has been compressed in this particular region. Because the air molecules next to the tuning fork has been compressed, the next set of air molecules will be less compressed and there will be more space between air molecules. So here there is some kind of high pressure at this particular region. So here at this particular region there is high pressure, and at this particular region there is low pressure of these air molecules. So that means here when this tuning fork is vibrating, it is creating a set of high pressured region and a set of air molecules which are under low pressure. So always remember, when you hear any kind of sound, so at that particular time one molecule which is vibrating, for example if tuning fork is vibrating, that vibration is passed on to the air molecules which is present around that particular tuning fork. So when that vibration is transformed to the immediate next air molecules which are present around the tuning fork, those air molecules start vibrating, and that vibrations, this particular air molecule will transfer to the next set of air molecules which are present around that particular air molecule. So that means here, for example, this is first air molecule, and if tuning fork is there here, then this tuning fork transfers these vibrations to this first air molecule, and this first air molecule will transfer the vibration to the second one, and this second air molecule will transfer the vibrations to third air molecules. So here only 1, 2, 3 air molecules will be not there. There will be countless number of air molecules around tuning fork. Just to make you understand about this concept, I am taking 1, 2 and 3 as example. So that means every air molecules which are vibrating around the tuning fork will transfer that vibrations to the next immediate air molecules which are present around it. So these vibrations transfer along the air. So that means these vibrations are traveling through a medium and reaching your ears. The sound energy which has been produced by that source using a particular medium travels and reaches your ear, and your ear can hear those sounds. So that means here, because of vibration there is sound, and because this vibration is transferring from one molecule to the other molecule, so that means sound is traveling through a particular medium. So even in solids, even in liquids, even in air, sound can travel. So what sound does is that the vibrations which is generated by the source, that vibrations goes on transferring to the next molecules which are present. So likewise the sound will be propagated through a medium, and then it will reach your ear, and then you can hear the sound. So here also the air molecules which are present around this tuning fork, those air molecules will be having certain amount of high pressure region which is known as compressions. So this particular high pressure regions are known as compressions, and all low pressure regions are known as rarefactions. So here you should remember these two words. One is compression and the other is rarefactions. So here compressions is the region where the vibrations has created an high pressure region. So that region can be known as compressions, and it has created a low pressure region because of the creation of high pressure region. So that low pressure region can be known as rarefactions. So this particular compressions and rarefactions continues through the medium. So then your sound will be transferred like that. So here, if a tuning fork is vibrating, it creates a kind of compressions around it, and following there will be rarefactions also. So here compression is there, here rarefaction is there. So similarly, this particular compressions and rarefactions create the next set of compressions and rarefactions. So again the next region after this rarefactions, that is after this low pressure area, there is again a high pressure area that is known as compressions, and again after this high pressure area there is low pressure area which is known as rarefactions. So like this it goes on till it reaches your ears. So again after this there will be high pressure regions which can be known as compressions, and again there will be low pressure region that can be known as rarefactions. So like this it goes on through the medium and it reaches your ear, and your ear can detect that particular sound. So always remember, these high pressure regions are compressions and these low pressure regions are known as rarefactions. So that means the vibrations which is created by this tuning fork, so that means to and fro motion which this particular tuning fork has got. So this to and fro motion, that is nothing but vibrations. So this vibrations which this tuning fork has acquired is transferred to the immediate air molecules which is there next to the tuning fork. So there certain high pressure region will be created among the air molecules. So that high pressure region can be known as compressions. Followed by that compressions, there will be a low pressure region which is known as rarefactions. And this process goes on through the medium, and hence that vibrations is transferred like that through the medium and it reaches your ear. So your ear acts as the detector, and your ear has capability to hear that particular sound because of vibrations. So if you want to understand this much more easier, then you have to take a particular slinky. So do you know what do you mean by slinky? Slinky is a particular toy which looks like this particular instrument. And if you hold this slinky from this particular side, for example, a person is holding slinky from this particular side, and let's say your friend is holding the other part of slinky like this. And if your friend supplies certain amount of energy from this particular end, that means if you shake that particular slinky from one particular side, then you can clearly see some part of slinky will be compressed like this, and other part of slinky will be free like this, and this compression will be transformed here, and this compression will be transformed here, and compressions will be transformed here, compressions will be transformed here, and finally you can experience that particular vibration from this particular side. So that means here you can see that compressions of that slinky, so that smallest amount of compressions which you can observe in slinky will be moving longitudinally in this particular direction. So for example, if your friend shakes this particular slinky from this side, you can see this particular compression moving along this particular slinky in a longitudinal direction. So because here the particles doesn't move till the detector. So for example, let's say this is an ear and there is a source which is producing sound. So sound is traveling through the medium and it is reaching your ears, and your ear is detecting this particular sound. So here the sound which is generated from this particular source, this particular object is not traveling till your ear. So the air molecules which are present around this source are also not moving to your ear. So here your ear is hearing whatever the sound is generated by this source, and also source is fixed at whatever place it is fixed at, but still you can hear the sound which is produced by this source. How is this possible? So that means the vibration from the source is transferred to the air molecules, and each and every air molecules is transferring the sound till it reaches your ear. That's why your ear is hearing the sound which is produced by this particular source. So that means here object is not moving towards your ear, but the vibrations are traveling to your ear. So that's why sound is traveling in the form of waves. So always remember, sound travels in the form of waves, because here the object which is generating sound is not moving, the particles are not moving, so just the particles are vibrating along its mean position, and that vibrations is transferred to the other particles, to their neighboring particles. Hence sound travels through a medium. So that's why here particles are not moving, particles are just vibrating in their mean position, and that vibrations is traveling. So that's why here sound travels in the form of waves. And always remember, these waves propagate longitudinally with respect to the direction of sound. So for example, if this source is producing sound, and if this source is producing sound in this direction, then the sound waves are in parallel to this particular direction of propagation of sound. So always remember, sound waves travel parallelly to the direction of propagation of sound. So here with this example you can understand, that is, when one of your friend shakes the slinky from the other side, then this compression what you can see immediately when your friend shakes that particular slinky, so that vibration is traveling along this particular slinky like this. So that means here this compression is transferred here, this compression is transferred here, and this compression is transferred here. So that means the compression which was there initially, now it is getting transferred to the next set of whatever wiring in that slinky is there, and it goes on propagating through that particular slinky. So through that you can see the compressions which has been generated due to shaking of this particular slinky, that compression is moving longitudinally along that particular slinky. So with this experiment, you can expect that these waves are parallel to the direction of propagation of that particular sound. So that's why this particular sound waves are known as longitudinal waves. Particles doesn't move from one particular position to other position. Here particles just vibrate in their mean position, and that vibrations is transferred to the next set of particles, and this particular process goes on. So hence sound waves can be known as longitudinal waves. So this is all there in this particular video. Now I have given a brief idea about sound, how sound works, and how sound requires a particular medium to travel from one particular position to other particular position. So always remember, whenever sound has to propagate from one point to other point, then a medium is required. So either solid medium or liquid medium or some kind of gaseous medium is required for this particular sound to propagate. So if there is no medium present, then there is no propagation of sound. Inside the atmosphere, inside the Earth's atmosphere, if a particular sound is generated, we can hear it clearly because we have air molecules around this particular atmosphere, and those air molecules carry the sound till our ear. So that's why we can hear the sound in our atmosphere. But if you go to the universe or if you go to the space, then in the space you have vacuum. That means you don't have any medium for sound to propagate, hence you cannot hear any kind of sound in the outer space. But in the atmosphere, because of the air molecules present in this atmosphere, we can properly hear the sound. So till now we have discussed so many things about sound. So the next concepts which are there in this particular chapter, I'll be discussing in my subsequent videos. Till then, if you want to learn more physics, chemistry and mathematics like this starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.